Hi and welcome. This video is going to look at amines for the A-level course, specifically the OCR spec we're looking at. So amines, nice and simple compounds. We have several different ones. The most common one you might see is this molecule. This is ammonia. Now, not strictly an amine, but all amines are related to ammonia. Have a look at the structure. We have a nitrogen with 3 hydrogens around it. We also have a lone pair of electrons, which is important later on. Now, the first amine we're going to look at is RNH2, and this is a primary amine. So what we've done here is we've replaced one of the hydrogens with an alkyl group. And that is a primary amine, so it's an R group to our nitrogen with 2 hydrogens. So an example of that might be methylamine. So the R group in this case is H3 to our NH2. So this is just our R group, our alkyl chain. Our next one is then our secondary amine. And this is where 2 of the hydrogens that we had in ammonia are now replaced with R groups. I'll just call that R1. It doesn't necessarily have to be exactly the same R group. You have different types of R groups attached, and that's our secondary amine. And then you've probably figured out now what our tertiary amine looks like. We're going to have our nitrogen not attached to any hydrogens, it's now attached to 3 alkyl chains. So this is our ammonia, and then if we replace a hydrogen with an alkyl group, we get our primary amine. If we replace 2 of the hydrogens with R groups, we get a secondary, and if we replace all the hydrogens in ammonia with R groups, we'll get our tertiary amine. So ammonia is basic, which means many different things to many different people. To chemists, we say basics are they accept protons. So you think of a proton is just a hydrogen that's lost its electron. So it's a H plus, we put it down as. Now our NH3, we saw earlier, I'll do NH2. So primary amine. We know it's got this lone pair of electrons. Now it can donate those that lone pair of electrons to this proton, or well, they can share them, but both electrons come from the nitrogen, forms a covalent bond with this hydrogen, so that's got a specific name. So I'm sure it's in your rack of your brain for it. And if you said there, dative covalent bonds, excellent. What happens is this H plus goes with our primary amine, and we get our dative covalent bond here, and that makes the nitrogen overall positive. The charge always carries across, so we've got a single positive on this side, we've got a single positive there then, and that is why we call amine groups basic, because of this lone pair of electrons can accept a proton and bring that on, and that's what basic is. So primary, secondary, tertiary, and even ammonia can do this, can accept that H plus because it has that lone pair of electrons, and it can draw that H plus in. So how do we get them? The first step is a substitution reaction. So if we were trying to make an amine prep, is we would have our, first of all, our haloalkane. We always tend to react things with haloalkanes. And I'm going to add ammonia to that. And what happens is it's a substitution reaction. So the chlorine breaks off and it goes and forms with one of the hydrogens, and we get hydrochloric acid. And then that leaves us with NH2 here, and then NH2 goes where the chlorine was. So just substitute around. So the chlorine substitutes off and goes to there, one of the hydrogens, but then goes with it as well. The NH2 goes to there. So that's why we call it a substitution reaction. The NH2 swapping with the Cl. Now this though can carry on reacting. We have our CH3 NH2 here as our product, and we've got lots of CH3Cl. Then that can then substitute with this, and the same reaction happens. We get our HCl formed, so that separates off, and now this NH2, well, it's lost one of its hydrogens, so it's NH, joins with the CH3 we had here. So we get two CH3s attached to our nitrogen. So, can you remember what the name of this was? Let's see if you were paying attention in the last board I showed. And I mean by name, primary, secondary, tertiary. Yes, the secondary. There's two there, just one hydrogen attached, and this can carry on reacting again and again. So generally, to make sure we only get a primary amine forming, we use an excess of NH3, and that means that all the CH3Cl reacts up quickly and doesn't carry on doing this reaction further on. The other way we can get amines is when we have a nitro group on an aromatic carbon. So let's prepare aromatic amines. And our starting point for this is our nitrobenzene, so our NO2. And what we want to get to is an amine, so NH2. So it should be pretty simple. So if we're going from NO2 to NH2, we're going to need some hydrogen. And we're going to just put in that as H for now. And it's a reducing agent, so I'm going to put it in brackets as well. I'm going to reduce down our NO2 to NH2. And our oxygen's got to go somewhere. That's also going to react with hydrogen. We're going to get some waters. So just to balance this nice and quickly, now we know we're going to add hydrogen to it. So get this hydrogen from a strong acid, but it's going to act as a reducing agent. We get NO2 here, so we're going to need two waters here to balance that oxygen. So that gives me 4 hydrogens there, 2 hydrogens there, so a total of 6. So I need 6 hydrogens there, and we use a conc hydrochloric acid to get there. We also, though, although this is balanced, we need a catalyst, and the catalyst we're going to use is tin. So we're going to use conc HCl plus tin as our reactants, and that's going to get our NO2 group changed into an NH2 group. Now this is a very common question to come up in the exams. How would you turn the NO2 into NH2? And they generally don't give you this. They ask for what reactant would you need to turn NO2 into NH2. So it's always a good one to remember, conc HCl and tin. And that is a quick video all on amines.